So step 0, write the equation from word equation, from word problem to word equation, from word equation to chemical equation. If the equation is not balanced, you have to balance just like we did in the step 0. Then I copy the equation again for the step 1 and I get the unknown and the known. The unknown is given in the word problem as determine the mass of water produced. So I need to find the mass of water. The known is the 25 grams of solid ammonium nitrate. So that is my known. Now that I have related both substances, water and ammonium nitrate, I'm going to do the molar ratios, okay? So that is going to be my second step. So what do? I need to relate both substances. I need to relate ammonium nitrate, which is this one, and water, which is the other one, okay? The water is in the products and the ammonium nitrate that is in the reactants. I do, but I don't affect others, with my work. Only you are the ones affected, positively or negatively. Only you, the victims. Now, what happens with the molar ratios? As I was telling you before, you have to relate the two substances, unknown and known. So, and then you have to write the mole ratios. Remember that when you don't see a number, it's invisible one. So I'm going to put all the invisible ones. Okay, I have one right here. I have one right here. Okay. Espérense que no me quiero cambiar. Ya, ya, ahí sí. So as I was saying, if you don't see a coefficient, means that it's invisible one. So I'm gonna put it in green. In green. One right there and the other invisible one over there. Okay? Because remember, this is useful for mole ratios. 1 and 1. Okay, now it's better. It's more appropriate. Now, what I do after is I write the molar ratios because I'm relating water and ammonium nitrate. I'm going to use the coefficients for water, which is 2, and for ammonium nitrate, which is 1. So the ratio is 2, 1. Okay? So how am I going to write it? Okay. Well, you can put 1 mole of ammonium nitrate over 2 moles of water. Remember that the number of moles is defined by the coefficient. Okay? So that could be 1 molar ratio, and the other could be 2 moles of water divided by 1 mole of ammonium nitrate, like that. Those are the two possible molar ratios. From the molar ratios, I can move to the next step, that is the molar masses. But what molar masses? Honestly, I get all the molar masses because I like how to do it, okay? But you only need from the substances that are in bulk. So you need to get the molar mass of ammonium nitrate and the molar mass of water. So on the substance A, I'm going to call ammonium nitrate. So the formula is NH4NO3, which gives me 1 plus 1 gives me 2 nitrogens, 4 hydrogens and 3 oxygens. Okay, so I'm going to get the easy molar masses. So this is going to be 2 times 14 grams. This is going to be 4 times 1 gram. And this is going to be 3 times 16 grams. Doesn't need to be exact, okay? How much is that?
80 grams.
80 grams. 80 grams of ammonium nitrate. Now, the molar mass, you can write it also as a conversion factor, okay? So you can write in 1 mole. And guys, I noticed that this was the most common mistake in your case, okay? The molar masses are always for 1 mole. 1 mole of a substance has 80 grams of the same substance, okay? It's always 1 mole and the mass. It's not 2 moles in mass or 3 moles in, no. It's 1 mole and the mass, okay? So you can do this as 1 mole of ammonium nitrate that has a mass, a molar mass of 80 grams of the same substance. Or, again, or, wait, 80 grams of ammonium nitrate is inside 1 mole of the same substance. Remember, I always relate the same substance, okay? For molar mass, I'm talking about the same substance. So I'm talking about ammonium nitrate. All the molar ratios are going to be ammonium nitrate. Now, the other molar mass I care about is water. Water, I know it by heart. So lucky. Okay, what happens with water? Very simple, not too complex. So you have just 2 hydrogens and 1 oxygen, which leads 2 times 1 gram in 1 times 16 grams. In total, this gives you 18 grams of water. So you have to write this also as a ratio, okay? So you're gonna have 1 mole of water that has 18 grams of the same substance, or you can say that there are 18 grams of water in 1 mole of the same substance. Those are the 2 ways to write the molar mass, okay? Molar masses are always for 1 mole, okay? 1 mole and the total mass. 1 mole and the total mass, always. Oh. Then keep it off the camera, okay? That's not something you can control. So after you do the third step, that is the molar mass, I'm going to move to the next step, that is doing the conversion procedure, okay? So that is going to be my last step. Conversion process. Okay, conversion process. Okay, I'm going to give you like a key, a path to follow, okay? So for stoichiometric mass-to-mass conversion, you always are going to start with the mass given, okay? From the mass given, you are going to get the number of moles of the substance given, okay? From the moles given with molar ratios, you can get the moles of the unknown substance. And from the moles of the unknown substance, you can get guys, do you listen to me?
Yes, miss.
Okay,
Yes, miss.
wait a second. Okay, guys, sorry. So from mass given to moles given, remember, mass to moles, you're going to be using molar mass. Okay, every time the mass is involved, you're going to be using the molar mass. From moles to moles, you're just relating moles, you're going to be using molar ratios, okay? And now, from moles unknown, what you can get is the mass of this substance unknown, okay? The mass unknown. So, again, from moles to mass, what are you going to be using? Molar ratio or molar mass? As I told you before, every time mass is involved, you're going to be using the molar mass. So that is the path I follow for this kind of exercises. Okay, but here I have two molar masses. Okay, so for mass given to moles given, I'm going to be using the molar mass of the given, of course. Okay, and from unknown to unknown, I'm going to be using the molar mass of the unknown substance. That's why we work like this. Okay, that's why we work like known and unknown from the first place. Okay, to keep working with the same idea, with the same concept. Now from this, it looks weird. It looks like blurry. Okay, now it looks better. I don't know what's going on sometimes. Okay, okay. Bueno. So I begin. Mass given. They're giving me 25 grams of ammonium nitrate. So I'm going to write it over there. So I'm going to multiply times, it says, the molar mass of the given. The molar mass of the given is here, ammonium nitrate, okay? Now, which one I'm going to be using? Am I going to be using A or B? What am I going to use? A or B? If I need to cancel grams of ammonium nitrate, I'm going to be using A. So 1 mole of ammonium nitrate in the top and the 80 grams below of the same substance. Right. Okay. We already accomplished this step. So I move on to the next step. It says from moles given to moles unknown. And it says I'm gonna be using the molar ratio. Okay. So I'm in this step now. I'm the molar ratio. So what molar ratio I'm going to be using? A or B? If I want to eliminate moles of ammonium nitrate,
B.
I will be using B. Okay. So now this is 1 mole of ammonium nitrate below and 2 moles of water in the top. With this, I eliminate the moles of nitrate, like that. Now, I accomplish the second step, and it says, from moles unknown to mass unknown, I have to use the molar mass of the unknown, okay? So, to use the molar mass of the unknown, I need to see what to eliminate first. So first, I have to eliminate the moles of water, okay? That's what I want to eliminate because I want grams of water, grams, mass of water, okay? So what conversion factor I'm going to be using, A or B?
B.
Okay, so I put the mole below and the mass like that. And with this, I can now eliminate the moles of water with the moles of water. And the remaining unit that I didn't erase is grams of water. Okay, that is what the problem is asking me. Mass of water. Okay, now what do you get? So in your calculator is going to be 25 times 2 times 18 divided by 80. How much did you get?
11.25
11.25 what?
grams of water.
Grams of water. Okay, and that's it. Determine the mass of water produced, 11.25 grams of water, like that. Do you have a doubt in any of the procedure? I know it's a long process, but when you get used to it, you will do it very, 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 very fast. So let's continue with this exercise. Okay, at a very high temperature, manganese is isolated from its ore. Manganomanganic oxide, from its ore, manganomanganic oxide, okay? By following balanced equation. That equation over there, is it balanced, yes or no? That is the first step you need to check. Is it balanced?
No.
No, it's not balanced. You can see only by taking a look to the manganese, you know it's not balanced. So how can we balance it? I'm going to do it. I'm going to write the equation again. Tell me, how can we balance this equation? Can you do it mentally? Can you do it mentally? All right. I mean, it's really hard to do it mentally. So you can follow the process. Okay, I'm going to give you a key. Okay, how to do this faster. Shirley, Luis, no, Luis, I know you have a problem with the camera. Okay, take a look at this. A key to balance faster, okay, like mentally balancing. Take a look. 4 and 3. I have 4 oxygens in the reactants and 3 oxygens in the products. So what I do to do it faster is I switch, okay? I switch from atoms, I put it as a coefficient. For example, the 4 from the reactants, I'm going to put it as a coefficient right there, okay? And the 3 from oxygen in the products, I'm going to put it here as a coefficient, like that. That's how I balance very fast. Now from this, you can have your oxygens balance, okay? Doing that, you have your oxygens balance. Now, what do you need to balance? What about aluminum? How many aluminums do you need?
4.
No, 4 times 2, 8. Okay? So you need 8 aluminum. So you need to put 8 before aluminum. Now, how many manganese do you need? How many manganese do you have in the reactants?
3.
You have 9. 3 as a coefficient and 3 as a subscript. So you multiply them, 3 times 3, you get 9. Okay? So because you need 9 manganese, the number you're going to put here is 9. Like that. Okay? Like this. And with this, your equation is already balanced. Now, if you want to do the whole process from the beginning, you can do it. I don't have any issue on that. Well, after your equation is balanced, okay, this is your step 0, balancing the equation. What comes after is analyzing what the problem is asking you. How many moles? I know not on moles and grams. Okay, I'm going to change. How many grams of aluminum oxide are made if 3,600 grams of manganic oxide are consumed? So I need to relate the two substances. I need to relate aluminum oxide and manganic oxide. Okay, those are the two substances that are related. Okay, now you might be thinking, okay, what's that? I cannot even pronounce it. I cannot even read it. It's there, okay? It is specified in the word problem. Manganic oxide is Mn3O4, okay? So you are relating the two substances. The substances that are related are manganic oxide and aluminum oxide, which is the other right here. Those are the two substances that are related. Ariane, your camera, please. So, in the first step, now I write the known and the unknown. The unknown is what the problem is asking me to find. It says how many grams of aluminum oxide. So the unknown is for me the mass of aluminum oxide, like that. That's what I need to know. And my known is the amount of grams of manganic oxide. So 3,600 grams of Mn3O4. Okay, those are the two substances that are related: aluminum oxide and manganic oxide. That's why they are related over there. From this, what you do is you get the from this what you do is you get, I'm gonna leave it there. You get the molar ratios. What are the molar ratios involved here? What are the molar ratios here?
3 moles of manganic oxide and 4 moles of aluminum oxide. And this
Just write the two substances, okay? Write the two substances and the coefficients that are involved, okay? 3 and 4, those are the coefficients you need to write, nothing more. Thank you.
me, so we can only put one possible answer, and then we can deduce the other.
Correct. Sorry, I have a mistake here. This is 4 and not 2. Yes, I mean, when you work on this, sometimes you don't even need to write the molar ratios. You can do it mentally. But when you are into the topic, when you are learning the topic, you need like to work step by step. As long as you continue working, it's going to be easier for you to make it like that. Now, I don't do any of this process. I only do the step number 4. That's the only step I do. But because I'm used to work with this, okay? Now, from the molar ratios, what's next?
Molar mass.
Molar mass of the substance of the known and the unknown, okay? The molar mass. So, as a homework, I want you to work on those 2 molar masses, okay? So we can continue in the next class. So calculate the 2 molar masses. Now, if you want to be sure that the molar mass that you got is correct, remember that last year I gave you, I don't know if I gave it to you. I gave it to the seniors. I don't remember if I gave it to you. It's this one, Merck PTE. And this one has here has a molar mass calculator, okay? So I put the substance and it gives me the molar mass. That's for you to check if what you did is correct. Remember that in the quizzes, if the molar mass is incorrect, everything is going to be incorrect, okay? So that one is only for you to use to make sure that what you did is right. If it's incorrect, you can do the corrections. Not for you to use it forever, okay? So I need procedure for that. I don't want you to just check it by using VerPT if you want.